Hi, today we're going to take a look at a system of inequalities. A system is when you have more than one problem thrown together and put on one graph. The solution to a system is where you have those two regions overlapping. If they're lines, what's the one point? If they're inequalities, where do the shaded regions overlap? And that's what we're looking at. We're going to take these two problems, break them up, do individual, individual, and then we're going to put them together to see where they overlap together. First one, y greater than negative 2x plus 1. Y equals mx plus b. We always want to find that y-intercept. Let's plot that, which is a 1. We then move using our slope, negative 2. It helps to turn that into a fraction, negative 2 over 1. So now we know we go down 2 and then to the right 1. Because we have just a greater than symbol and there's no equal sign, we have a dashed line. Now, along with this, we need to shade one side of that line or the other. So we need to pick a point, any point, as long as it's not on that dashed line. I like the coordinate 0, 0. When we plug it in, things end up canceling out. So take x, y, let's plug them in here, and we get 0 greater than negative 2 times 0 and 1, which is 0 bigger than 1. Does this statement make sense? No, 0 is not bigger than 1. Okay, so since that doesn't work, that means this does not work. You have two possibilities, either yes, no, right, wrong, true, false. This does not work. This is wrong. This is false. So the other side of this line has to be true. That's the side that gets shaded in. Let's try the second one. We're going to look at y less than or equal to x plus 3. Start with our y-intercept. In this case, it's 3. We're all the way up here. We now need to move using our slope. The slope is that number in front of x. We have no number, but we can put a number there. Put a 1. Turn that 1 to a fraction, 1 over 1. Now we know we can go up and over. We can also do the same in the reverse. We could go down and back, down and back, down and back, as many times as we want. Because we have an equal sign here in our problem, that now says we're going to have a solid line. So connect those dots with a solid line. We then need to shade. Pick a point, any point. I like 0, 0. Why? Because when I plug 0 into my problem, things end up canceling out. It's an easy number to deal with. So let's take them, put them in there. Is 0 less than or equal to 0 plus 3? Is 0 less than 3? Yes, this statement is true. I like that. So that means this side is true. Because you have only two options, true, false, this works. This side is false. That's not the answer. So we shade in our true side. Great. Now let's take both of these and put them together over here. So what do we know? We're green, green, dashed, and we go that way. Blue says we're here and here, and we shade everything that way. I need to know where do the two regions overlap. Well, I only have one shading up here. I have nothing here. I have just one here. Over in this corner is where we overlap. So what do we need to do? We need to exaggerate. We need to color in that section to say this is where everything overlaps. Everything there, there, and in between. So a solution to this system is anything in this colored in black area over here. So what does that mean? Well, is that coordinate a solution? Yes. Is this coordinate a solution? Yes. Is this a solution? No. Now, what about if things lie on the lines? Is that a solution? We're going to say no. Why? Because it's on a solid line or on a dashed line. That dashed line means it's everything creeping up to that dashed line but never actually touching it. However, on the other side, if I have an answer on that line, the answer is yes, because it is solid. That solid is included in those answers. And that is graphing a system of inequalities and finding your solutions.